In this tutorial for LabVIEW with Mindstorms NXT, we're going to look at the difference between the block diagram and the front panel, and we're also going to be looking at the difference between constants, controls, and indicators. So we'll start with an example that's got a motor block inside a loop that is repeating forever. And to set the power for this, we would normally right-click on that terminal and create a constant. And we'll see the default setting of 75 that we could change to 100 for full power, or we could change it to 0 if we want the robot to stop, or we could even put in a negative value if we want the robot to go in a reverse direction at some speed. But what we want to do here is we want to actually create a little interface that will allow us to control the motor's power while the robot's running from the computer. So for a start, we need to make sure that our program is targeted to the computer. And you see mine is because it's got main application instance down here. If yours has got the name of your NXT brick, then you can change it over by going up to File and Target to, and yours would say Target to Computer on there. Because I'm already targeted to the computer, I've got targeted to NXT. What we're also going to do is delete that constant and instead create a control. Now where the control appears, if we double click on this control, you'll see that it's appeared on the front panel. Well, it'd be kind of useful to have the front panel and block diagram side by side. So the easiest way to do that is from the window menu and then tile left and right. And you see we've got our front panel over here and our block diagram over here on the right. And objects that like controls, and also we'll see indicators, will actually have icons for those controls and indicators appearing on the block diagram. And you can always get from one to the other just by double clicking on the edge of one, and it brings you over to the other. Now, having a remote control sort of interface where we've got to actually type in the number that we want for the speed of the motor power might not be so good in all cases. So we've got alternatives, like for example we could create a control that is a pointer slide, and we can drag that out, and we can also change the scale. So instead of our power going from 0 to 10, we'd really like to go up to 100. We could go from 0 to 100, but it actually might be kind of nice to go from negative 100 up to positive 100, so that we can go forwards or backwards. And now we're not going to need this particular control anymore, so I'm going to delete that, and instead we're going to wire in our slider to our motor power, like so. And so every time we go through the loop, whatever value is on the slider will be fed into the motor. So if I run this, and now we can run from the front panel or the block diagram. I'm going to run it from the front panel. Nothing happens. That's obviously because the motor power is set to 0. If I slide this forward, you'll see the robot goes forward. If I go too far forward, it'll fall off the table, so I better bring it back. And you see if I go at a reverse motor power, it backs up. If I bring it back to 0 or close enough to 0, the robot will stop. Actually, I'll just stop that program so it doesn't go any further. Okay, so far so good. Okay, so that's an example of a control. What about an indicator? Well, for an indicator, let's do something with a sensor value. So we'll take a read sensor block, and then we'll set that to read light, and let's read the light with the LED on. My light sensor's on port 3, and that's what the default is, so that's good. And then on the back of where the scaled value comes out, we can right click on that and create, this time we want an indicator. So controls are for inputs, information we're putting into the system, and indicators to read values coming out of the system. And so if we run this program, what you'll see is we get the value of 22 displaying on the front panel, and as I move my hand in front of the light sensor, that value changes. So far so good, but there are a whole bunch of other sorts of indicators. So again, I've right clicked to bring up this palette, and then from the first box in the second row we get a bunch of numeric indication. Meter's kind of nice, and again we can change the number here by just typing in. If we want to change our scale so that, say here it goes up in tens, let's say I want it to go up in 20s, I could just type in 20 here, and now the scale will go up in 20s if it's going to fit okay. And now if we run the program and I move my hand in front, oh, nothing changes in the meter. Reason for that is because I forgot to wire it in over here. So I need to wire that meter to the output from the light sensor, run the program, and now our meter will change as the light value changes. So you get some nice feedback from the system. So with a combination of controls and indicators, you can imagine having students create quite an interesting and sophisticated remote control system for a robot. And that's the basics of controls, indicators and constants. Why don't you have a play around and see if you can make your own remote control.